You wake up one day, you have the Sweat Simulator add-on installed, but you do not see it in the M panel. Well, what gives? First of all, you have to select an object, not two objects, a single object, and then it will show up. How does it work? Well, you select your target object. I'm just going to make this slightly more interesting. And then you say, apply the Sweat Simulator to that object. Now, you're going to see that automatically. It just works, right? And it maintains your original object, and now you have a separate but connected sweat object that references this surface, right? So if I was to create a monkey, maybe with some like subdivision, it doesn't matter. You do Sweat Simulator, now it's connected to Suzanne, okay? And from that point on, you pick settings, and they're super simple. There's not much to think about. So surface is obviously what are you simulating on, and you're going to see it takes very natural paths as if let me enable this here, as if, you were crying or something. So it follows the contours of the mesh. You pick that, but then you get more interesting. So first of all, do you want instances? Okay, so it's actually points that we instance little like spheres on. The reason for this that you would want it is it gives it more dimension, right? And I have it curved to the, to the normal of the surface, but also I believe you need this for motion blur. So I just leave it on. The density is that. It's how much. So if I set this to 1, it's going to be almost nothing, right? And look at how it pools on the bottom. If I set it to 100, it will be a lot. This is something you can totally keyframe. So let's have 100, go for a few frames, 0. And this way, we'll have one burst of spawning, and that's it. Notice, by the way, this is simulation nodes dependent. So you go to frame 1, you hit play. Okay. What else do we got? Let's clear keyframes. Let's do 10. The size is a post effect, meaning it's not really part of the simulation. It's more of a visual thing. This is the scale of the points, and then therefore the instances. The speed is the speed. If I make it really low, it's almost as if it's not moving. If I make it incredibly fast, it will go on the contours, but, incredibly fast. The age is so that you don't have particles that necessarily live forever, although you can have that. This is so that, you're going to have particles that pull down here, and you don't want them to exist forever. So if I set this to a very short thing, newly spawned particles will, they'll die fast, or you can do the opposite. Finally, to make sure that not every point is identical and follows the exact same path, we add a bit of noise, right? So if I bring the noise to 0, it's just going to flow on the surface. Nothing special here. It pools where it would pool, and that's fine. As you increase this, and you don't want to do it this much, it will kind of randomize. So this is important for if you have, like, rain on a car window or whatever, where you want some visual interest so it doesn't just go straight down, right? So these particles are slightly different from each other. You then can control the quality of the noise. So I'm going to bump this up just to be a bit ridiculous. So here you can see they're kind of big waves. This is what the noise size does. So if I bring it up to 15, it's kind of the inverse of what you'd think. So now it's high frequency noise, whereas with the noise scale of 1, very slow kind of movement, which is fine. And then noise evolution makes it so that that noise changes over time. So if I set this to 0, everything here will follow. You can see they're kind of pooling in the same place. It's kind of weird, the same sections. So the evolution ensures that it's not going to get stuck, in a sense. Okay. At this point, all you need to know is that it's simulation nodes. What that means is once you're happy with the settings, you can take this and hit bake. As you can see, it's incredibly fast, especially for the calculation it's doing on dense geo. You can also do this on a animated or, in fact, deforming mesh. So let's just do a bit of procedural animation. So let's do hash frame over 30 so that it's spinning. And then the sweat will only spawn on the top surfaces. This deserves, it's earned, the sweat modifier. So make sure it's selected, boom. And now you'll see it's kind of interesting the way it works. Let's select that there. So it spawns on the top, it pools where it would be a very kind of advanced looking physics simulation super quickly. So there you go. That's how you use it.